morning, everybody. I'm glad that you've been here for the training workshop on applied microeconometrics that we do at ERF for the fourth time. This time it will be undertaken by myself and Dr. Rasha. I'm Shahir Zaki, Associate Professor of Economics at Cairo University and working as a part-time senior economist here at the Economic Research Forum. I work mainly on trade and macroeconomic issues, and I'll let Dr. Rasha present herself.
Good morning, everyone. Good morning, everyone. We are glad you are here with us. I am Rasha Ramadan, Associate Professor at Faculty of Economics and Political Science, Cairo University, and part-time economist here at the ERF. I am the microeconomist part of this workshop. I'm mainly working on poverty and food security and gender issues in developing countries. So looking forward for these 2 days. Hopefully you will get benefit from it.
So I suggest before we start, we make a tour de table. So each one of you will present her or himself. What's the institution where you're working, and what are your main, research interests, okay? So let's start.
I'm Ayat Asi. I'm come from Palestine. I work in PCPS, Palestinian Central Bureau of Statistics. I working in national accounts.
I'm Iman Muaddab. I'm Tunisian. I'm PhD student, and I work in at Center of Research on Study and Social Economic in Tunisia.
Hi everyone, my name is Sousan Musa. I'm a lecturer at the Department of Economics, University of Khartoum. Mainly my research was in macroeconomics, but now I'm transitioning into micro, and I'm doing a research on informal labor sector.
Hi everybody, I am Zaki Al-Hilo, teaching assistant at Khartoum University. My research interests are macroeconomics and institutional economics.
Hello everyone, I am Dalia Sabbagh. I work at IFRI International Food Policy Research Institute, mainly on SAM building and general equilibrium. Thank you.
Hi, my name is Mai Mahmoud. I'm also transitioning between finishing work at IFPRI, International Food Policy Research Institute, and starting PhD in Economics and Public Policy at Tufts University. My research interests are economic transformation and environmental economics.
Assistant Professor at University of Tunis and part-time at German Business School.
Assalamu alaikum. I'm Mustafa from Morocco. I'm working for the High Commission for Planning, is the National Office of Statistics, and my main research are on labor market issues, informality, gender, and so on.
Hi everyone, I'm Ahmed Dawood, research analyst at the Egyptian Center for Economic Studies. My main work is on population issues, poverty, and also in gender issues, so I'm very close to Dr. Rasha. I hope to learn something from you today. Thank you.
Hi everyone. I'm Soumaya Gharara. I'm from Morocco, PhD student from Morocco. I'm working on the impact of tax holidays on FDI attractive. Thank you.
I am Marwan Ikira. I am a PhD student at University Hassan II of Casablanca. I am a PhD student. My doctoral thesis focuses about the evaluation of a conditional cash transfer program in rural Morocco. It's a program to encourage poor families to keep their children in school.
Good morning. Hi, I'm Joanna Abdel Ahad from Lebanon. I'm currently working at ESQA on SDGs and youth.
Assalamu alaikum. I'm Munia Al-Azali from Morocco. I get my PhD last year. I worked on evaluation of program of literacy, and I still interested by microeconomics method for to evaluate other program.
My name is Rami Al-Azze. I'm an economic affairs officer at UNCTAD in Geneva, and I'm also a PhD student at the Graduate Institute. My research focuses mainly impact evaluation of conflict on development outcomes.
Hey, good morning. I'm Heba Ghunaim, an economic lecturer in the German University of Cairo. My research focus is on public policy evaluation. I'm interested so much in welfare games, in the social welfare application, and the new insurance policy of the public health.
Hello, my name is Marie Gagne. I'm French. I'm intern at the IAF with Sheikh Zaki and Rasha Ramadan. And I've just made an exchange in the Cairo University in the Faculty of Economic and Political Science. And I'm at the master degree.
Good morning, my name is Zeli Seyadji.
So thank you. Today what we're going to do, we'll start with the first session where we'll present the general objectives of the training workshop and what we'll be doing during the 2 days. Then we'll have a second session on, it will be more theoretical, where I will present the main problem that we'll try to answer over the 2 days. Then we're going to have the lunch break, and after the lunch break, we're going to start a more focused part on the microeconometric tools with Dr. Rasha in the first part on today's PSM and difference in difference. And for all the for all the tools that we're going to have 2 sessions. The first session will be more the theoretical part of I would say the econometric tool itself, and the second part will be more a hands-on training using Stata. So I think all of you have your laptops, you have Stata installed on it, right? That's it. So before starting, do you have any questions, any queries, any? Okay, so we can start. Okay, so the general objective of this workshop, as you can see, it's entitled Applied Microeconometric and Public Policy Evaluation. And actually, the tools that we're going to present can be used for both macroeconomic research questions and microeconomic research questions. Because, as some of you said, some of you are working on informal labor market or poverty. So those are more micro-related issues. But again, we can examine the effect of subsidies or the effect of tax policy, for instance, on poverty, on empowerment, and so on. So all the tools that will be presented now can be used in both macroeconomic research and microeconomic research questions. During the first day, we'll first present the important point of the fundamental problem of causal inference in statistics, because one of the main things that we face in the applied work is the difference between correlation and causation. Because the fact that we have a correlation between two variables does not lead necessarily to a causation between these two variables. So it's important to identify whether there is a causation or not, because in public policy evaluation, the point of causation is fundamental. Because if I want to examine the effect of I will take the example of Takaful and Karama, because we're going to repeat this several times during the workshop. So after the structural adjustment program that was implemented in Egypt with the International Monetary Fund, the Egyptian government. So after كده. Okay. So after the implementation of the structural adjustment program implemented by the IMF and the Egyptian government, a social safety net program was implemented in starting 2014 and then effective in 2016, if I'm not mistaken. And it was called Takaful and Karama. Takaful means solidarity and Karama means dignity. The idea of it's a conditional cash transfer program in order to help poor people face the price hikes due to the structural adjustment program. So in order to evaluate the effectiveness of this program, we need really to have some tools that help us examine to what extent this program was effective. So if, for instance, income of poor has increased because of this program, we must really be sure that the increase in income is effectively attributed to specifically this program, not to anything else, not to the improvement in the macroeconomic situation in general. So this is why the point of causal inference is very important in the analysis of applied microeconometrics. So that's the objective of the first session that I'm going to start now. And then we're going to have an overview of the potential solutions that are suggested by the literature. So we're going to see two main, I would say, groups of solutions that help overcome the problem of causal inference, okay? Where we'll see randomization and non-experimental methods. And then for randomization, we're going to see that they are costly, they take time, so we'll not go into the details of this. But all the methods that will be presented today and tomorrow are mainly non-experimental methods. So we'll start first with the matching methods based on the propensity matching scores and the propensity scores weighted regressions with difference in difference. So all this will be covered by Rasha after the lunch break. And after the coffee break, we're going to have the first hands-on training session using Stata to apply propensity score matching. Tomorrow we're going to have a Okay. So for tomorrow, we're going to start the first part of the day with the difference in difference methods and how to implement them on Stata. And after the lunch break, we're going to see the panel data models for both fixed and random effects and how to implement them on Stata. And again, I mean, the data set that we'll use perhaps is a microeconomic data set. It's from the Egyptian Labor Market Panel Survey, but we can use any type of data in order to examine, similar, different research questions, but with the same econometric tools. It's important, to highlight that some Stata skills will be required for this workshop. So you're all familiar with Stata. Is there anybody who had never used Stata before or similar softwares, eViews, SPSS, SAS? Sorry? Which one? Okay. So, it's not very far from R, significantly different from SPSS, and significantly different from eViews. Yes.
Generally, when we use data sets and we use Stata software or Python software or SAS software, we must find the same result, I think.
Yeah. It doesn't. Definitely. In general, unless there are some minimal differences in terms of the options that you can add to any command, but in general, you should get the same result. But in general here, we're using in this training workshop Stata because it's user-friendly. Most of the tests are already implemented in Stata, and it's regularly updated. So this is why, in general, we rely on, especially for microeconometric data sets. But perhaps for really macro issues where we're going to run, for instance, I don't know, a vectorial autoregressive model or an error correction model or really time series econometrics, in general, EViews can be somehow more user-friendly than Stata. But again, even, I mean, for time series econometrics, you can perfectly implement them in Stata without any problem, okay? So for the commands that we're going to have, that we're going to need in Stata, they will cover 4 main things. So the descriptive statistics, and it's important to have, I mean, a flavor of the data set. What's the structure of the data set? What are the main variables? Which variables are continuous? Which variables are discrete? What are the different values, whether we have extremes or not in the variables, and so on. So this is why the first point that we're going to cover, hopefully by the end, after the coffee break, is just to have a flavor of the descriptive statistics of the data set itself. Then how to have some graphs in order to get also a sense of what are the characteristics of the data set. What are the commands that we need in order to implement the regressions themselves in terms of the multivariate analysis? And by multivariate analysis, I mean that we have one dependent variable and more than one independent variables. And what are the post-estimation commands that we have to implement in order to test the robustness of the model? For instance, whether we have endogeneity or not, whether we have multicollinearity, whether we want to extract the values, I mean the results into an Excel table in order to put them in the paper, and so on, okay? It's important also to have a do file, because as you will see, if you have a complete do file, especially if you're working with a co-author, it's very important to have a full do file with explanations, with details, in order to easily reproduce your work, or to let your co-author double check, I mean, something in the regressions themselves. So it's very commendable to have a self-explanatory do file with all the details, with all the comments that you want to have. And we're going to see also this in the do files that we're going to give you. For the descriptive statistics and graphing, it's important also, if we talk more about this, that why is it important from your perspective? I mean, why is, in general, we have to start with some descriptive statistics? Why we don't directly jump into the empirical part? What do you think? Yes?
To see the data, if they are outliers or something like this.
So 2 things, you said 2 things. Your name is? Zaki. So Zaki said 2 things. So first to see the data, and second to see whether we have outliers or not. What else? Why it's important to undertake a descriptive analysis before implementing the empirical analysis itself?
To understand the data and check what we can manipulate from it or what we can get from it.
Not manipulate, but what we're likely to obtain, perhaps. Yes?
To check if the model that we are going to apply appropriate or not for the data.
Okay. Exactly, because if, for instance, I want to examine the effect, the determinants of labor force participation, and my variable is a binary variable, whether I'm working or not. So if I have a binary variable, I cannot run a simple OLS. I have to run either a logit or a probit or any discrete choice model. So it's important to really understand the characteristics of the data set before we start working on it. And again, if one of the independent variables is a categorical variable, let's say that takes the value of 1 if the person is illiterate, 2 if he has a primary level of education, 3 preparatory, 4 secondary, and 5 more than or higher than secondary education. So if I introduce this variable that takes the value of 1, 2, 3, 4, 5 in the regression as it is, Stata will understand that it's a continuous variable, while in reality it's not continuous. It's a categorical variable. And it will be misleading to interpret the results as if 1, 2, 3, 4, 5 are continuous or are numbers, because they are categories. So the alternative would be to introduce the variables as separate categories. So we'll not do this unless we understand the characteristics of the data set itself. Okay? Also, it helps us sometimes have a first correlational analysis, meaning that if I'm examining, for instance, the effect of trade liberalization, which is a more macro issue, on labor informality. To what extent trade liberalization increases or decreases the informal sector in an economy, especially informal employment, okay? So this means that, in general, we have two strands in the theory. The first strand of the theory says that if we have more trade liberalization, so firms will face more competition, and if they face more competition, they will have to hire more productive workers, and if they hire more productive workers, these workers will have to be formal or informal? Formal, because I will not have a productive worker or a skilled worker and give him an informal employment. So this is why more trade liberalization, process leads to less informality or more formality. That's the first strand of the literature. But the second one says that if we have more trade liberalization, there is more competition, so firms tend to reduce their cost, and if they tend to reduce their cost, they will have to hire workers who are informal. So this means that more trade liberalization leads to more informality. So just to understand what are the dynamics I have in my data set, I can just run some simple correlation analysis between the values of tariffs and the values of informal employment by sector, and see what's the preliminary correlation between the two variables. If it's positive or negative, then it will give me a sense of what I have in my data set. Perhaps later in the empirical work, it can be different, because I will control for other things. I will run a more robust regression. But the advantage of running some preliminary correlation analysis will help me motivate my research question and the policy issue I'm examining. Okay? If you have any question, don't hesitate to interrupt. And also, it's important to check the assumptions of the model, because as I said, if I have a dependent variable that's binary, I cannot consider this variable as a continuous one. And if it's continuous variable, for instance, income or wages, I cannot run a probit model with a continuous variable. So this is why understanding all the variables I have in my data set and having some cross tabulations in Stata between, for instance, employment, whether I'm employed or not, and my wage. Or, sorry, not my wage, my income probably, because if I'm not working, I'll not have a wage. Or education and income, or gender and employment, and so on. So all these cross tabulations will help me understand what I have in my data set. And then I will be able to somehow expect what I'm going to get once I run the empirical work. Okay? Then, for the multivariate estimation commands, those are the three methods that we'll cover during the 2 days. So, as I said, today we'll start with the propensity score matching. Tomorrow, before the lunch break, difference and difference. And after the lunch break, dependent data models. Did any one of you use such methods in any kind of empirical work? Which one? Okay. Fixed effects for macro or micro issues? Micro. Okay. Sorry? Micro. And you?
I use fixed effect in international finance and education economics.
Okay, so it was more a macro issue. Okay.
difference in difference in micro in a health analysis, estimating the effect of a certain policy before and after, and in panel data in a macro analysis, something related to trade and economic integration, fixed effects.
Okay. So we're going to see that theoretically how they can be, derived, and empirically how they can be implemented in Stata. Third, for the post-estimation commands, as I said, for post-estimation commands, they are commands that in general we undertake after we estimate a certain empirical model. So mainly either they are for extracting the results or checking the robustness of the results. Those are the two main groups of post-estimation commands. So for the extraction of the results, first we are going to see what are the types of commands that we can use in order to save the results. Then checking the assumptions of our estimators, whether they are correct or not, to what extent our results change with if we control for heteroscedasticity, for instance, or for multicollinearity, and to obtain also the predicted values of the model and the marginal effects if we're estimating a probit model or something similar. For an important thing in the, as I said, in the do file is to have a study that is reproducible and that's replicable. What's the difference between reproducible and replicable? Reproducible is that I can reproduce exactly the same results if I run the same do file. This means that I can reproduce the study itself. Replicable, that for instance, if Dalia is going to run a paper to examine the effect of a conditional Keynes transfer on the Egyptian economy, I will do it for the Lebanese economy. Okay? So in this case, I can replicate what she did with the same do file, but with another data set for another economy. So this is why having a self-explanatory and detailed do file is very helpful in this regard. Okay? And definitely in this case, as you all know, in Stata we have three types of files. We have the DTA files, which are the data sets themselves, so the data set we're using. The second types of files is the do file, where we're going to write all the commands that we have, or the log file, where we have the extraction of the results. So it tracks the history of what we run in Stata. There is another type of data, which is the ado file, but the ado file is the programming files behind the commands. Okay? Most of the commands that we're going to see are built-in, so we're not really going to implement new commands, because especially now, 2 weeks ago, Stata 16 has been launched, and it's even more powerful than Stata, I think, 13 that we're going to use. Most of the commands are already implemented for both the estimation methods and the post-estimation commands, and even for the extraction of results. And in general, if you have a relatively old Stata, like for instance Stata 13, and there is a new command, you can download the command from the Stata online help and put it in the corresponding letters in the ado files. Did any one of you do this before? Because I have to go, if no, I have to go to more details of this. No, so in general, what we do, so for instance, if there is a command called outrack2. So outrack2, it's a post-estimation command that we run in order to extract the results of what we've run. So in Stata in general, if I run, let's say, a regression reg y x1 x2, so Stata will give me the regression itself. And then what can I do in order to extract this regression into an Excel file with the stars and the brackets and the standard errors and so on. So there is a post-estimation command called outreg. One of the commands, there are several, but one of the commands is outreg2. If I have Stata 12 or 13, outreg2 is not implemented in Stata. So in this case, what I have to do, I search for this command online, and I will find two files. A file called outreg2.hlp and outreg2.adu. So the outreg2.hlp is the help file, meaning that if I, in Stata, if I run help outreg2, I will get a window explaining the details of outreg2. And the adu is the programmed command that is implemented in Stata. So I will download these two files and then go into the Stata folder. Probably it will be in program files or something like this. Then in Stata, I will have a folder called adu. In adu, I will find two folders. A folder called update and the other one called basic. It doesn't matter, I will put it in which folder, but the most important thing is that in each folder, I will find several subfolders with different letters, A, B, C, D, and so on until Z.
Excuse me, I think we can run find it.
Yes, but sometimes Stata cannot find them automatically.
Okay.
And that's the alternative if you do not find them through the find it command.
After we can make SS install in the name of the package. Install Stata software, we look for this package.
Sure, I mean, but in general, even with both, sometimes the commands are developed on private websites and they are not captured automatically online. And if they are not captured automatically online, then you will have to, for instance, if I develop a code and I put it on my website, and I'm not making it public, but I published a paper in Stata Journal, and it's still not automatically searchable online, then that's the more, I would say, manual way to add the commands. But definitely, the easiest solution is just to write find it in commands, and then Stata will search automatically for this new command. But if Stata doesn't find this command, so that's the manual way to implement it. And the most important thing is to put this command in the O folder, because the command starts with O. Okay? Then we already talked about this. So econometrics that are not built into Stata. And finally, as I said, sometimes we have to program some commands, which is not the case now because most of the commands are already implemented. But in general, if we have to program new commands, we do this in the adu file because that's the language behind the commands themselves. So those are the references I used for the introduction because most of the tools rely on the slides that were initially developed by Dr. Raghi Asad and Caroline Kraft in another training workshops. There is a very good textbook called Micro-econometrics Methods and Applications of Cambridge University Press, Cameron and Trivedi. And this book is really good for those who really want to go into the details of the applied microeconometrics tools at both the theoretical and the empirical level. And they developed a guide especially for Stata with this book in 2009, how to implement all these commands all these tools in Stata. So we'll send you anyway the slides, the do files, the data sets, and the papers that you will need after the workshop. Okay?